In this video, we are given the area and we are asked to find the minimum amount of fencing to be used to enclose a pasture. And so this is a little backwards of the first problem that I did. A farmer plans to fence a rectangular pasture that abuts a river on one side. Now, certainly one thing that you might want to consider doing is to draw a picture. And so I've got my cute little river. Put my water in there. You don't really have to get this fussy. Any old picture will do, as long as it semi-accurately represents what you're trying to do. And so we have our area is equal to 180,000 square meters. Okay, and now we're asked to find the minimum amount of fencing needed to do that. All right, not so bad. So the area is 180,000 square meters, but the area is also equal to the length times the width. In our case, the perimeter is equal to 2 times the width plus the length. All right, so let's go ahead and rewrite L in terms of the area and the width. Well, the area again was 180,000, and that equals the length times the width, which means that the length is equal to 180,000 divided by W. So if we substitute that into our perimeter, then that gives us our perimeter is equal to 2W plus 180,000 over W. So let's go ahead and take the derivative of this. So we have dP dW, and we have 2 plus. And now this is going to be a negative 180,000 over W squared. Okay, so now if you're unsure of this, go back and take the derivative yourself. This is going to be, as the power rule, is going to be W to the negative 1. Drop the negative 1 down, decrease it by 1 to negative 2, and that's where you get the negative from in front of the 180. And then that's where you get the squared on the W down here. So if we go ahead and set that to 0, 0 is equal to 2 minus 180,000 over W squared. Well, that means that this is negative 2, so that means that we have 2 is equal to 180,000 over W squared, which means if we go ahead and multiply by W squared and divide by 2, then that also implies that W squared is equal to 90,000. Okay, so if we take the square root, W then is equal to plus or minus 300, but negative 300 doesn't make any sense, and so W just is equals to 300. All right, now you can go ahead and take the second derivative of this and find out that it is in fact, and let's go ahead and just do that quick, d2p dw squared. The derivative of 2 is 0, and so you have the derivative of this, which is going to be bring down the negative 2, gives us 360,000 over W cubed, and that is always greater than 0 because W is 300. So this is concave up, and so this is a minimum. Okay, that says that is a minimum by the second derivative test. So now we've got the minimum width, and so now let's take a look at the length. What do we need for that? Well, in order to do that, we just take 180 and divided that by 300. Okay, so we got L is equal to 180,000 divided by W, which is 180,000 divided by 300, which is equal to 600. And so there's our, let's use green here to kind of signify the answer. And so our perimeter, or dimensions in this case, because we're looking for the dimensions, width is equal to 300, length is equal to 600. Okay, so this is the minimum. You need a minimum of 1,200 meters of of fencing in order to enclose this 180,000 square meters of pasture area as long as it abuts a river. And again, we went through all the same steps. We wrote a primary equation. Okay, this is the one that wanted to be optimized. And then we wrote a secondary equation. This is the one that we had information for. And very often, this is the way that people operate. I need this much area. How much, how can I build that in the cheapest way? That's really the question. So we went through and we said, make a list of all variables and unknowns. Okay, well, we kind of did that through our picture here. Okay, determine the equations needed to be optimized, and so that was our perimeter. Most of the time, you'll need to have at least one supporting equation. In this case, it was our area. Determine the viable domain for the variable. Now, we didn't really do that until the end, and so that's entirely up to you as to where you do that. But very often, you have a restriction on the domain, typically positive, and then it says find the derivative and solve. Okay, so we went through all those steps, and by and large, those are all the steps that you need to go through.